If AGI transforms science, industry, and governments, it will also transform something much more personal: the way each of us thinks about work. For centuries, intelligence has been one of humanity's most valuable resources. Learning difficult skills required years of education. Experience was earned through time. Expertise was scarce. That scarcity shaped the global economy. But if advanced intelligence becomes abundant, scarcity moves somewhere else. Perhaps creativity becomes more valuable. Perhaps leadership. Perhaps trust. Perhaps uniquely human experiences. Or perhaps entirely new professions appear that we can't yet imagine. Just as software engineers, social media managers, and drone pilots were almost impossible to predict centuries ago, history repeatedly reminds us that people are remarkably poor at imagining the jobs of the future. Few people living during the Industrial Revolution could have predicted commercial aviation. Few people using the first computers imagined video creators, app developers, or AI researchers. The future after AGI may be just as surprising. But uncertainty also creates fear. Some imagine a world where billions become permanently unemployed. Others imagine unimaginable abundance, where machines produce goods so efficiently that basic necessities become dramatically cheaper. Reality could lie somewhere between those extremes. Economic systems may evolve. Education may change completely. Governments could experiment with new policies to support populations during periods of rapid technological transition. International organizations may develop new agreements governing powerful AI systems. Or competition between nations could accelerate even further. The direction depends less on technology itself and more on the choices humans make while developing and deploying it. Because AGI is not automatically good. And it is not automatically bad. Like electricity, nuclear energy, or the internet, it is a tool whose consequences depend on incentives, institutions, and human decisions. This is why conversations about AI safety, governance, transparency, and international cooperation have become increasingly important. The challenge isn't only building an intelligent machine, it's building systems capable of using that intelligence responsibly. Perhaps the biggest misconception about AGI is that there will be a single dramatic moment when everything changes overnight. History rarely works that way. The printing press didn't transform Europe in a day. Electricity didn't modernize every city at once. The internet took decades before it reshaped commerce, education, entertainment, and communication. AGI may follow a similar pattern. At first, only researchers notice. Then industries begin changing. Eventually, daily life feels completely different. Looking backward, future generations might struggle to imagine life before intelligent machines became everyday collaborators. In that sense, the arrival of AGI may not represent the end of human history. Instead, it could mark the beginning of an entirely new chapter. A chapter where scientific progress accelerates beyond anything previously experienced. Where diseases once considered incurable become manageable. Where space exploration becomes dramatically cheaper. Where climate solutions improve faster than expected. But also a chapter requiring wisdom equal to our technological capability. Because creating intelligence may ultimately prove easier than governing it. So what happens after AGI? The honest answer is that nobody knows. Not because experts haven't studied the question, but because humanity has never experienced anything quite like it. Every prediction contains uncertainty. Every scenario depends on choices yet to be made. What seems almost certain, however, is this. The world after AGI will not simply be a faster version of today's world. It could become a fundamentally different civilization. The question isn't whether that future will arrive exactly as imagined. The question is whether humanity will be ready to shape it. Because history has always been defined by the tools we create. Fire, agriculture, writing, electricity, the internet. Each invention expanded what civilization could become. AGI may become the next tool on that list. Or it may become something history has never seen before. Either way, the decisions made during its earliest years could influence not just one generation, but the future of our entire species. And decades from now, people may look back on this moment and realize that the age of artificial intelligence wasn't the destination. It was only the beginning. History shows that every major technological revolution creates winners and losers. The steam engine reduced the need for physical labor. Electricity transformed manufacturing. Computers automated calculations. The internet changed communication forever. But AGI could be different for one simple reason. Previous technologies mostly replaced human muscles. AGI may replace, or dramatically amplify, human thinking. That doesn't necessarily mean every job disappears. Instead, the value of many skills could change faster than societies are used to adapting. Imagine a small architecture firm. Today, designing a skyscraper requires large teams of specialists working together for months. With AGI, a handful of engineers might generate hundreds of safe, optimized designs in a single afternoon. Doctors might diagnose rare diseases with near-instant access to the latest medical research. Lawyers could analyze decades of legal precedent within minutes. Teachers might receive personalized lesson plans for every student. Scientists could simulate experiments that once required years of trial and error. The goal wouldn't always be replacing humans. In many cases, humans could become supervisors, decision-makers, and creative directors while AGI performs enormous amounts of technical work. But history also suggests that transitions are rarely painless. Entire industries could reorganize. New professions would emerge. Others might disappear entirely. The challenge isn't simply unemployment, it's adaptation. Human societies are remarkably good at adapting over decades. They're much less comfortable adapting over months. And if AGI develops faster than governments, businesses, and education systems can respond, the transition itself may become one of the greatest challenges. Yet employment might not be the biggest story. Science could be. Think about how scientific progress normally works. Researchers gather evidence, design experiments, wait for results, analyze data, write papers, review conclusions, repeat. Each step takes time. Now imagine an AGI capable of reading millions of scientific papers, identifying hidden connections across disciplines, generating new hypotheses, designing experiments, and evaluating outcomes almost continuously. Instead of waiting years for breakthroughs, discoveries might arrive every week. A new battery chemistry could improve renewable energy. That cheaper energy powers larger computing systems. Those systems accelerate AGI research. The improved AGI discovers better materials for computer chips. Those chips make future AGI even more capable. Progress begins reinforcing itself. Economists sometimes describe technologies as general-purpose innovations. Electricity wasn't valuable because of light bulbs alone. It transformed transportation, communication, factories, medicine, and nearly every industry built afterward. If AGI becomes a true general-purpose intelligence, its effects may spread through civilization in the same way, but potentially much faster. This raises another fascinating possibility. What if AGI begins solving problems humans considered impossible? Diseases without treatments, efficient nuclear fusion, climate modeling, food production, space propulsion, new materials that don't yet exist. Each breakthrough would unlock entirely new industries, and those industries would generate even more data, more resources, and more opportunities for further discovery. The pace of innovation could become difficult to predict. Some researchers call this an intelligence explosion. Others argue that real-world engineering constraints, limited energy, regulation, and economics would naturally slow progress. No one knows which scenario is more likely. What most experts agree on is simpler. If AGI reaches human-level general reasoning across many domains, the world after that point probably won't stay the same for very long. But technology doesn't exist in isolation. Every powerful invention changes incentives, and incentives shape politics, economics, and international competition, which leads to perhaps the most difficult question of all. Who controls AGI? If only one company develops it first, that organization could gain extraordinary influence. If several companies succeed simultaneously, competition might accelerate deployment. If governments become the primary operators, national security could dominate decision-making. If AGI spreads rapidly around the world, coordination becomes even harder. History offers many examples where revolutionary technologies spread faster than international rules. Printing presses, industrial machinery, nuclear technology, the internet. Each forced societies to build new institutions after the technology already existed. AGI may follow a similar pattern, except this time, the technology itself could actively assist in improving future technologies, creating a feedback loop unlike anything humanity has experienced before. Imagine waking up tomorrow to a world that looks exactly the same. The streets are still full. Your phone still buzzes with notifications. Planes still cross the sky. People still go to work. But overnight, something fundamental has changed. For the first time in history, humanity is no longer the most intelligent, problem-solving species on Earth. Somewhere inside a data center, an artificial general intelligence, an AGI, has just solved problems that thousands of the world's best scientists could not. It can design new medicines, invent better batteries, optimize entire economies, and write software faster than millions of programmers combined. Nothing explodes. No robots march through cities. No dramatic warning appears on every screen. Yet this moment could eventually become more important than the invention of agriculture, electricity, or the internet. Because from this point forward, history may begin moving at a speed humanity has never experienced before. But what actually happens after AGI? Would millions lose their jobs within months? Would science suddenly accelerate? Would governments still be able to control such a system? Or would the biggest change be something almost nobody is talking about? To answer that, we first need to understand what AGI really is, and why it represents something fundamentally different from every AI system we have today. Today's AI can already perform extraordinary tasks. It writes essays, generates images, translates languages, discovers patterns in enormous data sets, and helps researchers solve increasingly difficult problems. But every current system has limits. Some models excel at language but struggle with long-term planning. Others master mathematics but cannot understand the physical world. Some outperform humans in narrow tasks while failing spectacularly outside their training. AGI changes that assumption. Instead of being designed for one capability, an AGI would be able to learn, reason, adapt, and solve unfamiliar problems across almost any intellectual domain. In other words, it wouldn't simply answer questions. It would understand problems, create strategies, improve its own methods, and transfer knowledge from one field to another, much like a human expert, except potentially much faster. History offers a useful comparison. Before electricity, nearly every machine depended on muscle, water, or steam. Electricity didn't replace one industry. It transformed all of them. AGI could have a similar effect. Not because it replaces one profession, but because intelligence itself is involved in almost everything humans do. Medicine, engineering, finance, law, education, scientific research, government planning, manufacturing, space exploration. Every field depends on solving problems. And if problem solving suddenly becomes dramatically cheaper, faster, and more scalable, the ripple effects could spread into every part of civilization. But change almost never happens all at once. The first days after AGI would probably look surprisingly ordinary. Companies would keep operating. Schools would remain open. Governments would continue functioning. Most people might not even notice anything unusual. Behind the scenes, however, organizations with access to AGI would begin testing its abilities. Researchers would ask it to solve scientific questions that have resisted decades of human effort. Pharmaceutical companies might explore thousands of potential drug designs simultaneously. Engineers could optimize aircraft, power grids, and transportation systems in ways that were previously impossible. Financial institutions would evaluate enormous economic models in minutes rather than months. The first breakthrough might not be visible to the public. It could be hidden inside a laboratory, a medical discovery, a revolutionary manufacturing process, a material stronger than steel but lighter than aluminum, or a clean energy breakthrough capable of reshaping global economics. This is one reason many researchers believe the earliest impact of AGI may appear in science before it appears in everyday life. And once discoveries begin accelerating, every breakthrough makes the next breakthrough easier to achieve. That creates something history has rarely experienced: progress feeding on itself.